Hello class. Before any practical session, please consider applying the safety procedure for the laboratory. For this experiment, we are going to investigate conduction heat transfer. Conduction happens when we have an object over a hot surface and we expect to have heat transfer from hot side to cold side. We can investigate this phenomena when we have a wall with a surface of A1 which is going to be perpendicular to the heat transfer rate. So imagine one side of the wall has temperature of T1 and the other side T2. T1 is going to be higher than T2. The position of the T1 is going to be X1 and the position of the temperature T2 is going to be T2. We expect to have relation between heat transfer rate delta T and delta X and A1, which is the area perpendicular to heat transfer rate. This proportionality can be converted to equality using a coefficient which we call it thermal conductivity, and we can write it in terms of Fourier's law, which Q dot is equal AK delta T divided by delta X. The negative sign shows the direction of the heat flux, which is going to be from high temperature to low temperature at the direction of positive X. For this experiment, we are going to use linear conduction apparatus, which as you can see in this picture, includes two sections. The upper section, which we can see here in this picture, is linear heat conduction HT11C, and the lower part HT10XC is a controlling system for the linear heat conduction apparatus. Let's investigate different parts of this apparatus. The main part of the heat conduction apparatus includes this column, which includes the hot part at the upper side. On the lower side, we have a cold side. And at the middle, we have a specimen which can be changed. So by opening this clamp, we can change this middle section. We have four different specimens: stainless steel, aluminum, and copper. As you can see in this picture, different specimens. The upper part has a heater, which is connected to the controlling system. The lower part, you can see we have a water circulating system, which is going to lower the temperature. There are several thermocouples connected to the upper side, specimen, and lower sides. All those thermocouples, they are connected to controlling system using these green wires. As you can see here, from T1 to T8, which shows we have 8 thermocouples, 3 upper side, 2 middle side, and 3 lower side. The flow rate of the cooling system is also monitored and controlled. This white cable connected to the electrical valve to control and read the flow rate. We can change the flow rate using this auxiliary knob. To control heater, we are going to use this knob to change the voltage of the heater, and to read the voltage, this selector knob is going to help us. By turning to the knob to the voltage, we can read the voltage inside this monitor, and by adjusting this knob we can increase or decrease voltage. If you want to read amp, because the heater power is going to be voltage multiplied by amp, you are going to select this, turn this knob to the amp to read the amp here in this monitor. After reaching steady state, you are going to read the temperature of T1 to T8 using this knob. This knob is going to, by selecting different temperature or different thermocouples, is going to show the temperature of that thermocouple inside this section. For more details, this picture shows all the labels for the controlling system. You can see T1 to T8 for our thermocouples. Selector knob to read the temperature of those thermocouples here in this monitor. Voltage and amp selector for the heater, and it is going to be shown in this monitor, and the unit is voltage and ampere, for the rest is there. And to control the voltage of the heater, we are going to use this knob. For the flow rate, this auxiliary control is going to help us to change the flow rate, and this main button is going to show us it is going to turn on the system or turn off. Now let's zoom in inside this column and see what type of linear conduction and what are the different parts of this section. This schematic picture shows different parts. The upper part is our heater, which is going to be connected to our controlling system. The lower part is our cooling system, which is going to create our cold section of the this linear conduction system. As you can see, it is going to be connected to the water tap, and we are going to consider water tap temperature constant. It comes to the filter and regulator and then valve, and it is going to be drained to the outside. There is an insulation material, as you can see in this picture. It's a white color with low thermal conductivity to create linear conduction inside our system. The specimen is going to be placed at the middle by opening the clamps here, and it's colored orange here. We have 4 different specimens to change and investigate thermal conductivity and thermal contact resistance. Because we have heater at the top and cooling system at the bottom, we expect to have heat transfer from top to bottom. 8 thermocouples placed inside this section, 3 for upper side to see temperature gradient in heated part, 3 at lower part, T6, T7 and T8, and 2 inside a specimen. If you want to investigate and find thermal conductivity of a specimen, you are going to just need T4 and T5 as they are placed inside specimen. Hello class, now let's start with the experiment. As you can see, all the cables they are connected are thermocouples here. The green cable thermocouples, 3 at the top, 2 for the specimen, and 3 upper side, which is the hot side. They're all connected through these 2 cables to T1 to T8, so 8 thermocouples. The water flow sensor is also connected through this white cable to this FW port, which is going to show us the water flow rate. Let me turn on the controlling system, but this by this main button. First, I'm going to check the voltage of the heater. So this connector can select the information I want. I want to select voltage. So as you can see, it is 9.9. Using this control, I can increase a little bit more to show the voltage of 10. To find power of the heater, we need to know amp. So using this selector, again I'm going to move to amp, and so voltage was 10 and amp is 0.95. For the cooling system, as you can see, this pipe is connected to the tap, and then we have regulator, valve, and this is the flow sensor. We have water circulations here, and the sensor is connected to controlling system, and using this auxiliary control we can change the flow rate. So to see the flow rate, I'm going to move this selector to FW to see the flow rate. So currently I can decrease, as you can see the number here decreases, and by moving this or turning it, it is going to increase. So currently it is 0.58 and the unit is liter per meter. So I have the cooling system and I'm going to wait to reach a steady state. And when I'm going to reach a steady state, when the selector here, T1, T2, T3, T4, T5, T6, T7 and T8 reach a steady temperature and they don't change by time. Usually when we say it's like the variation of the temperature in a minute is negligible, we are going to consider as a steady state. Okay, now let's go back to okay, now we can see different specimen here. We have brass with 13 millimeter diameter, stainless steel with 25 millimeter diameter, aluminum with 25 millimeter diameter, and brass with 25 millimeter diameter, which is already inside the linear conduction system. To open and change the specimen, you are simply going to open the clamp at the front and at the back, and the heater part we are going to put it aside. So as you can see, we have 3 thermocouple attached to this part, so I'm going to put it there, and we can move this specimen. As you can see, 2 thermocouples are attached to this specimen. So let me check the numbers for these. As you can see here, this is number 4 and this one is number 5. So thermocouples number 4 and 5 are going to attach to the specimen, and this is the lower part. So if you want to open the thermocouples, you are going to easily just turn this screw and open the thermocouple and replace it with this. And you can see we have two holes here to put those thermocouples here and replace with this one. So let's close the upper part, close the clamp. So we need to do for the both sides. So let's check. Now everything is ready. We can have 4 different specimens, different voltage, and for the water tap it's going to be constant and we're not going to touch it.